Welcome back. Today we're going to talk about TPC 300s and TPC 400s. A TPC is simply a track power controller. It's nothing more than a device that goes between your transformer or power supply and the track that allows you to control the voltage to the track either manually, like you would in conventional control, or you have the ability to turn the power on to a full 18 volts on the track for operating command or legacy equipped locomotives. The advantage to having a TPC between your power supply and the track is that you can use your remote, either a cab one or a legacy remote, to turn your track power on and off from the remote, as opposed to walking over to a conventional transformer and turning the power off manually. We're going to walk through how to connect a TPC to your legacy base and also your TMCC1 base, and how to connect it to your powerhouses or your conventional transformers. Before we get there, I want to explain the differences between the TPC 300 and the TPC 400. The product number for a TPC 300 is a 14189. The TPC 300 is capable of putting up to 270 watts or 15 amps of power to the track. That's achieved by using two of the 12866 135 watt powerhouses from Lionel. 235 watt powerhouses go to the TPC 300, which then goes from the TPC to the track. The TPC provides the circuit protection required to use 15 amps on the track. The TPC 400 is capable of producing up to 20 amps of power on your track. This is achieved, before we go there, the TPC 400 is a 6-14179, and it uses up to 280 watt powerhouses. Those 180 watt powerhouses are 6-22983. You can use a conventional transformer such as a post-war ZW, KW, or any other AC transformer you may have available to you. The TPCs were designed originally to use the 135 watt or 180 watt powerhouses in tandem to produce twice the amount of amperage on the track. It's also important to note that you'll need a 6-14194 powerhouse cable if you plan to use either the 180 watt or the 135 watt powerhouses with the TPC. This is simply nothing more than a cable that has the two male Molex connectors on the end that you plug in the powerhouse Molex connector on, and it has two ring terminals that go to the TPC. So prevents you from having to cut off any connectors from the powerhouses and gives you clean wiring all the way around. It's also important to note that if you have one or more TPCs or any of the TPC variant of family devices, such as ASCs for accessory switch controllers, block power controllers, accessory voltage controllers, etc., you're going to need one command-based cable. This is nothing more than a cable that goes from the computer port on your command base and produces two wires on the end, a green and a red. The red wire is commonly considered as DAT or data, and the green wire is considered COM or common. The command base, be it a legacy base or a TMCC1 base, communicates with the TPC family of devices through these DAT and COM wires. You only need one command-based cable. Once you install that between your base and your TPC, if you add additional TPCs down the road, you simply daisy chain those connections to the other devices that you add. So let's go ahead and cover how we connect a TPC to either our legacy base or our TMCC1 base, or both bases together. To begin wiring our TPC to the command base, what we're going to do is we're going to use our 6-14191 command base cable. There's actually cables are available in two lengths, 6 foot long and 20 foot long. Again, the 6 foot length is 14191, and the 20 foot is 6-14195. We begin by connecting our red wire to the terminal labeled DAT and our green wire to the terminal labeled COM. As you can see clearly in the picture now, we have COM and we have DAT. On this side it says AUX plus and AUX minus. Those terminals are not used. Do not connect anything to the AUX plus or AUX minus terminals on a TPC. The next step in connecting our TPC is to put the power into the TPC. You can use any transformer you'd like, such as a post-war ZW, KW, modern era transformer by a different manufacturer. It doesn't matter. What you want to make sure of is that the amperage on the transformer is high enough to justify the use of a TPC. Something that puts out 3, 4, 5 amps of power is a bit light. You can use it, but we recommend something with higher amperage, something such as a powerhouse, which is what the TPC was designed for originally. To put the power in, you simply take your transformer leads and connect them to the power in terminals on the TPC. The outermost terminal is hot, and the next terminal in is neutral or common. What we actually have for you today is a powerhouse that had the connector chewed up in shipping, so we've actually clipped off the Molex terminal and stripped the wires back. If you have any powerhouses like this where you suspect the connector is bad and you decide to clip it off, you want to remember that the rib side of the wire, or the cord, the rib side is AC ground and the smooth side is AC hot. The hot terminal will get, if you're using a post-war ZW, we'll use something such as terminal A, B, C, or D. And the neutral terminal will use ground, or common, or U as in uniform. Let's go ahead and get this powerhouse connected so we can move to the next stage. We now have AC hot to the hot terminal and ground to the neutral terminal. What we've done here is we've connected the power from the TPC to the track. The terminal labeled A goes to the center rail of your track, and the terminal labeled U goes to the outside rail of the track. This is important because when you're operating in a conventional environment and you trigger the horn from your remote, if A and U are reversed, the horn will actually trigger the bell, and the bell will trigger the horn. Now what we've done is we've added a wire here to the neutral or the U terminal of the track output. This wire here will actually connect to the U post on our command base or our legacy base. That wire is responsible for getting the command signal that comes out of the command base to the outside rails of the track so that it broadcasts a strong command signal for your locomotives to receive. The primary connections to our TPC are now complete. We still need to do one thing though. We need to take our command base cable and plug it into our command base. This is a TMCC1 command base. If this is all you have on your railroad, what you do is simply take the command base cable and plug it into the command base on the computer port. Finally, you'll take the wire that we have connected to the U terminal of track out and connect it to the U post of the command base. Again, this is so that this wire, which ultimately connects to the outside rails of the track, will broadcast the 455 kilohertz signal through the rails to the antennas of the locomotives. All right, let's take a quick moment and explain what happens when you add legacy to this setup here. We bring legacy into the equation. Here's what occurs. Because we have a TMCC1 base and a legacy base, we need to use the Y cable that comes with the legacy base. We take the end that's labeled legacy base and plug it into the computer port on the front of the legacy base. We take the opposite end of the Y cable and we use the end labeled command base and plug it into our TMCC1 base on the computer port. We then take the end labeled serial COM and connect our command base cable to that. Finally, we take the wire from the U on the track output of our TPC and we connect it to the U post of the legacy base. We want to make sure that we take it off of the TMCC1 command base and put it onto the legacy base. If you remember from the previous video, only one base can broadcast the command signal to the track. So if we have a wire from the U post or the U on the track output going to both the TMCC1 base and the legacy base, the two signals will actually cancel themselves out and you'll have no command control on the track at all. So that wire from the U on the track output gets connected to the U on the legacy base. Here we've taken the TMCC1 command base out of the equation entirely. I want to cover briefly how to hook the TPC to just the legacy base. We use our command base cable and we plug it into the front of the legacy base into the computer port. We take the wire from the U on the track output side and connect it to the U post on our legacy base. Now, wiring the TPC is now complete. To recap, we have the command base cable going to the DAT and COM terminals on the TPC. We have our power supply going to the power in on the TPC. We have our track connected to the power out or track out, A and U, and we have a wire from the U terminal on track out to the U post on the legacy base. Having the TPC in the equation is simply providing you with a device that's capable of receiving the command signal from the computer port and controlling the track voltage from the power supply to the track. It does a couple things for you. One, it allows you to maintain conventional control of the track power so that you're able to run conventional engines using the wireless handheld. Two, it provides circuit protection. The circuit breaker here is rated at 20 amps on this TPC 400. It's capable of using 280 watt powerhouses to produce 20 amps of current in the section of track it's connected to. And finally, in the event of an emergency and you need to hit the halt button or the emergency stop button on your remote, either your cab 1 or your legacy remote, when you hit that halt button, the TPC will immediately cease putting power to the track. Now that we have our TPC connected to our operating system, we need to program the ID number of the TPC. TPCs are capable of responding to two different types of ID numbers. We can assign them as a track, TR address, in which case there's 10 numbers available, TR0 through TR9. Or we can assign them an engine ID number. There are 99 numbers available for that. We can use engine 0 through engine 98. Let's go ahead and program our TPC now and assign its number. We move the program run switch to program. Make sure that our powerhouse is turned on, so power is applied to the TPC. Using our cab 2 or our cab 1, we press TR, the button underneath TR for track. We press TR and 1. We're going to call this track 1. And now we press the set button. As long as I hold down the set button, the program LED is flickering, confirming that it is in fact receiving the command. Once I let off the set button, it stops flickering. The ID number for the TPC is now assigned. So we move the switch back to the run position. From this point forward, this TPC will only respond to the address of TR1. For demonstration purposes, let me assign an engine number. Go ahead and move the switch to program. We're going to press engine 9, 8 and set. The LED again flickers to confirm that it's receiving the command. Let off set, it stops flickering. Move it back to run, and from this point forward the TPC will only respond to engine 98. Let's go back and make it track 1 for the rest of this video. Again, we put it in program, press TR1, set. The LED flickers to confirm it's taking the program. We let off set, slide it back to run, and now we're ready to further program our TPC. There are 2 ways to program the functionality of your TPC once you've assigned the ID number. Those 2 modes of operation are command and conventional. In command, it simply allows you to take your remote, press the ID number, in this instance track 1, and hit the boost button. Once you hit the boost button, it applies 18 volts of power to the track. That's great for operating command control locomotives. But there are times where you want to run conventional locomotives that are not equipped with TMCC or legacy. So in an instance such as that, we program the TPC to function as a conventional device. That's done, or once that's done, you're able to use the red thumb wheel on the remote, either the cab 2 or the cab 1, and as you increase the throttle clockwise, the voltage to the track increases. As you turn the throttle counterclockwise, the track voltage decreases. The direction button interrupts the power to cycle an E unit. Whistle provides a positive DC offset to the track to activate the horn or whistle. Bell on the remote provides a negative DC offset to the track to activate the bell. For this section, what we want to do is we want to program our TPC to act as a command TPC. So to do this, we leave the program run switch in the run position. Using our cab 2 or cab 1 remote, we press track 1. If you can see this LED down here, I'm going to press L, and then I'm going to press set. The LED stays on solid to confirm that it's receiving the command. Now what happens, I'm going to place this car on the track. And when I press TR1 and boost on my remote, 18 volts will immediately be applied to the track. Pressing boost now. Right now we have 18 volts on the track. To turn the track power off, I can do one of 2 things. One, I can turn the throttle counterclockwise and my track voltage will gradually turn off. Press boost again to turn the power back on, or I can press aux1, the straight arrow key, aux1 and 0, and that will shut the track power off. One more thing, turn the track power back on by hitting boost. If I hit the emergency stop button or the halt button on the cab 1 or the cab 2, power is immediately taken off of the track. So 3 ways I can turn track power on and off in the command setting. I can dial the red thumb wheel counterclockwise, I can press aux1 and 0, or I can press the halt button. All 3 methods are capable of shutting the power off to the track. As I mentioned earlier, you can also program your TPC to work in a conventional environment. To do that, you leave the program run switch in the run position. Using your cab 1 or cab 2 remote, simply press TR1 and the M button at the bottom of the remote. And watch this LED as I press M and then I press set. Now the TPC knows that it's to work as a conventional unit. What this means is we're capable of running conventional trains, those that are not equipped with TMCC or legacy, with our wireless remote. So what I'm going to do is move this into this shot. We have here a conventional Polar Express locomotive out of our Polar Express set. What I'm going to do is I'm going to go ahead and hit the boost button to show you what actually happens. As long as I hold down the boost button, the TPC will gradually increase power to the track. When I let off the boost button, that track power will drop down to 0. Here we go. Now I'm letting off the boost button. That's the primary difference between conventional control and command operations, or command control. Now, I can take the red thumb wheel and increase my voltage. As I turn this throttle, I'm slowly increasing voltage to the track. As you can see, I can control the speed of that conventional locomotive. The more I turn the red thumb wheel clockwise, the faster the locomotive goes. As I turn the red thumb wheel counterclockwise, the train slows down. This effectively gives you the same control that you receive using a conventional transformer, as you turn the handle up and turn the handle down. But with the TPC in the equation, I'm no longer fixed to one spot. I can walk around, total wireless control of conventional locomotives. I want to also show you that as I apply track power and the engine begins running, I can activate the air whistle in this tender by simply pressing the whistle button. In the case of the cab 2, I'm going to pull the whistle slider down. On a cab 1 remote, I hit the whistle button and my air whistle will sound. If this tender were equipped with a bell, I could hit the bell button, the bell would turn on. Now I want to go ahead and hit the direction button. What this will do, you'll see the train stop because I'm interrupting the track current. Press direction now. Train stops. I let off the direction button, and as you can see, that engine has the lockout switch in the off position, so it continually runs. We'll reach inside the cab, turn the direction switch back on, press direction again. Locomotive begins to run in reverse. Direction, we're in neutral. Direction, we're in forward once again. Because I can change the performance of my TPC while it's in the run position, I don't have to go to my TPC. If I want to switch it back to run command-equipped locomotives, I simply go to my remote, I press TR1, L, and set. Now when I press the boost button, my power is at a full 18 volts. Turn the track power off, simply press aux1, 0. The TPC, again, is designed in 2 variations, the TPC 300 and the TPC 400. 300 will allow you to use 2 135 watt powerhouses. You do need a cable, that 6-14194 cable, to use your Molex connectors to put the 2 together to bring it into the TPC. TPC 400 is capable of handling 20 amps or 280 watt powerhouses. You're still going to need that same power cable to get your Molex connectors from the powerhouse to the TPC. And also your command base cable. It's going to be required to get the communication from either your legacy base or your TMCC1 base to the TPC. There are additional features that the TPC offers. All of those are available in the manual. The manual is available for download at lionel.com under Customer Services, Resources, and Owner Manuals. Simply type in the 6-14189 or 6-14179 number. The manual will pop up and you can download it. Those features include how to set the maximum voltage, the minimum voltage, how to operate other manufacturers' products with the TPC. Thank you for joining us, and hope this has been educational.